Okay, I'll be sharing the PDF with you all. You all can hear me?
Yes, ma'am.
Okay, 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 okay. So we were on to the topic of risk management and the project scheduling in our last class. This topic was not completed, so we will be covering the rest of the part. So what we have discussed about, we have discussed about what is a software risk and how we manage the software risk. So software risk was basically the potential problem that could arise. So we always consider that in the direction of that the problem is going to arise. So how we are going to handle that problem is basically covered in this management of the risk. So first thing what we do is we try to avoid the risk, then we detect it if it is not avoidable and it is occurring, then we detect it, then we try to control it, and after that we try to manage it, right? So this was, all these things have been discussed in our earlier class only. What was the basis for the different types of the software risk, right? It could arise into this interface module, it could be because of the poor knowledge of the tools to the expert member or the team member, it could arise because of the less skilled force which are not very much proficient into the programming skill. Then there could be any of the management issues. Then update in the hardware or hardware resources may arise. Then extra support may be required. Customer risk and external risk, commercial risk, all these factors were discussed. Then there was this risk table monitor, how we monitor the risk and how we prioritize the risk according to the probability of the occurrence of the risk. What we used to do, we used to increase the priority of that risk, and the risk that has got the highest probability of occurrence used to be handled first by the risk monitoring team or the risk management team. Then after that, these were the important points into the risk management field. What was that? Risk avoidance, risk detection, then risk control, and risk control, and then the risk recovery was also there. We have covered everything, how the risk have been avoided, how it was detected, then the control and the recovery. This graph was also being described. So today we will be starting from, I think, by these points the risk avoidance was happening with the help of anticipating the risk and by making use of the risk tools. Then the detection of the risk was done by all these important factors, analyzing the risk, categorizing the risk, and then prioritizing the risk. And the risk control was also being performed with the help of these three important points by risk pending, resoluting the risk, and categorizing the risk into the class that they are not solvable. Then the recovery of the risk was happening, and there were three kinds of the risk recovery. First was the full recovery of the risk, then the partial, and then to propose the alternate of that particular situation if risk cannot be recovered. So that was the last point that have been discussed into the class. Can you remember all these points? Huh? Can you remember that we have discussed all these points? You all can hear me or not?
Y-
Yes.
Actually, I was not in that class, but I learned some points from it, and I will study it. Inshallah, we will
Okay.
see. Mhm.
Okay. Okay. Because it is necessary today to revise all the points, because the unit is not completed, then only we will be able to move further in this particular unit. So risk part is this much only. We just try to avoid the risk. If it is not avoidable, then we detect it, then we control it, try to control also, and at last we try to recover the risk, right? And there are three things in the risk recovery. The situation first is related to, we recover the risk completely or the fully recoverable situation is there, partially we can recover, or if we cannot recover at all, then what is the option left to the team? The option left is to propose an alternate solution of that particular risk, right? So till here we have completed. We are going to start it from here only, which is basically the formulating a task set for the project. Now there is a requirement for the formation of a task set. Task set means a set that comprises of the various kind of the task, and whose function should be to prioritize or to schedule those particular tasks which are present into your task set. As the name represent, it is a set of the various kind of the task, and as a number of tasks is present into a particular set, so there arises a need of scheduling or prioritizing those tasks. Scheduling means which task is going to be performed onto which particular number. A particular task is going to be taken first, then there would be another task that would be taken next, then third, and then fourth. That is basically considered as the scheduling of your task. Now there are certain factors which affect the task set for the project. Project means we are talking about the development of a software that will be called as the task project. So the factors are, first is our technical staff expertise, then we have the customer satisfaction, after that the technology update, and then the point of the full or partial implementation of the project arises. Then the next point is our time allocation, and then we are going to see what is module binding, milestones, validation, and verification. Right, so we are going to discuss all these points. First one is the technical staff expertise. It is going to be explaining to us what is the technical staff expertise. It means how much expert are technical staff in the timely implementation of a particular project. Means in whether the staff members or whether the team members who are involved in the development of a particular project are expertise in their particular domain, do have the expertise in their particular domain or not, right? That is being considered into the technical staff expertise. Now, for that, the meetings have to be conducted weekly and the status reports are also to be generated. Second criteria that needs to be taken into consideration is the satisfaction of the customer. So, a proper timely information regarding to the status of the project needs to be communicated to the customer also. So it is going to be the another factor into our list of tasks or into our set of the task. What is that? It says that what is the progress of our project currently needs to be communicated timely to the customer also. For example, if the development team is into the design phase or even if it is into the coding phase, then it is the responsibility of the team that it should inform about the progress of the project to the customer also, and also always keep the satisfaction of the customer into the mind. It shouldn't be like no communication thing. The customer has informed about the requirements or the specification, then only at the time of the delivery of the product the customer will be called or the customer will be communicated. It shouldn't be like that. The customer should be involved, he should be informed. There shouldn't be any kind of the communication gap arises between the customer and the organization. Then we have the next factor, which is called as our technology update. Technology update means, as we all know, that the updation in the tools and the existing test modules keeps on arising. Therefore, the technology should be very much adaptable in the latest update that is being happening, right? And the project that we are implementing, that should be very much efficient towards any kind of the technology update if it has happened during the development of the project only. Next point is our full or partial implementation of the project. So in the case the project is very large and to meet the market requirements, the organization has to satisfy the customer with at least a few modules, and the remaining modules can be delivered at a later stage. For example, what happens in this case, the project that is being asked by the customer is of very huge size, right? It is not a very simple software project, or it is not a easy, I will say, or it is not a project that is going to take the less amount of the time. So what could happen in that kind of the situation? there is a possibility of delivering the partially implemented project. Partially implemented project means if there are certain modules of the project which have been implemented, then those modules can be delivered to the customer, and the team can simultaneously work on to the another module that have not yet been uh, formed, or that have not yet been created. So all the modules which are completed, they can be delivered, and the another part of the remaining modules can be delivered on to the later stage, right? Next factor into the task set is our time allocation. Right. Time allocation means all the phases should be divided into the proper timely manner. That this is the amount of the time that will be dedicated to this particular phase of the software development. This is the another module, and we are going to give only this much amount of the time to this particular phase of the software development. So time allocation is also being performed. Then we have the next important point, which is our module binding. Module binding means module has to bind to various technical stuff for the design, implementation, and the testing phases. Obviously, what we always do, we always keeps on developing the entire software project into the set of various modules. So at last there arises a need of binding those particular modules together. So that binding means coming or integrating the modules together. So that comes into our module binding. Then the next task is our milestones. Milestone means the outcome for each phase has to be mentioned in terms of the quality, specification implemented, and the limitations of the module and the latest update that can be implemented. Milestone means on the completion of each and every phase, there arises a need of mentioning how is the quality of that particular module which is being developed into this particular phase, right? What are all the specifications that have been implemented in this particular module? Then what are all the limitations of the module? And after that, what are all the latest updates which could be implemented into this module, right? Next thing is your validation and the verification. Validation and verification are the 2 points that we are also going to discuss into our next unit, which is going to cover the testing phase of our software development life cycle. So in the task set, we also have this validation and the verification part. That means the number of the modules verified according to the customer specification and the number of the modules validated according to the customer expectation, they also needs to be specified. So there are two things. First is verification means the module is fulfilling the customer specification, means whatever the requirement being asked by the customer, this module is verifying all those requirements, right? That comes under the verification part. In the validation part, it basically covers the expectations of the customer, that these are all the points which were like specifying the customer expectation. So this module is fulfilling this much of the expectation of the customers, and that is why it comes under the validation part. Verification parts include the customer specification, meeting the customer specification, and the validation part includes meeting the customer expectation. So all these are the factors which affect the task set for the project. What I have discussed till now, I have discussed about the technical staff expertise, the customer satisfaction part, technology update part, full or the partial implementation of the project, how the time is being allocated, how the modules are being bind together, then what are all the milestones that have been achieved, and after that, the validation and the verification. All these points are clear or not?
Yes, ma'am. Yes.
Okay. Moving on further, we are going to discuss about how to choose the task of the software engineering, right? So these are all the points that are going to tell us how the tasks are being chosen. So the
Ma'am, excuse me.
hmm, hmm,
So, ma'am, in timing part, for
hmm,
example, a customer needs the software
hmm,
in 1 month, and
hmm,
we are providing him the time 1.5 months. In this
hmm,
case, they are needing urgently in that they don't show flexibility in their time. In this time, what should we will do?
Then it will be depending. If the customer is not providing the flexibility, then the software development team has to decide, has to see all the requirements specified by the customer. First of all, the team has to check whether the requirements that have been mentioned by the customer will be fulfilled in that much duration of the time, right? So that is being basically covered under the feasibility study, whether the team is feasible to perform all these requirements in that particular amount of the time or not. If yes, then the team is going to take that project. Otherwise, it is always in the hands of the company that it will not be able to that particular project. Second option is the company can see that there is always an option of rapid application development model, right? In spite of going through the SDLC model to deliver the product onto the time, the company can opt for the rapid application development model, whose main feature is to just develop the project in very short amount of the duration of the time. So these are the two important factors. If the company will be able to deliver the project by making use of the red model, a quite efficient a quite efficient project, I would say, then the company is going to take the project. Otherwise, because it is always in the uh, all the points are being cleared into the starting phase only, into the time of the requirement specification part only, that this much amount of the time the customer do have, and the company is obviously going to tell that this much amount of the time is being required by the company. So if both the things matches, then only the company takes the project. Otherwise, the customer always have the another option, or they have to come on to a certain point that only these are the modules which could be delivered in that much amount of the time. So if the customer gets agree that yes, in 1 month only these particular modules are required, then also the company can move ahead. So it is always the like there is a situation in which both the parties have to negotiate about. So that happens in the case. Okay.
Okay, ma'am. Thank you.
Okay. So moving on, we are going to now discuss this point, which is our how to choose the task of the software engineering, right? So first is our scope, then we have the scheduling and planning, then the technology used, then the customer interactions, then the constraint and the limitations, and then the risk assessment, right? So first of all, we need to just understand. Yes. Anybody wants to say anything?
Uh, Nothing, just mom, we can't see the slides, so
You can't see the slides.
yes, right now we can't see the slides.
Right now you can't see. Now you can see or not?
Not.
Yes, now it's clear
Yeah, I think you must
from
be
my
able to
side.
see the slides now.
Yes, it's very visible.
Visible, na? Okay, you just check your system whether any setting is not being proper.
Now it's visible.
It's visible. Okay. I think it's just 1 or 2 seconds or minutes it take to display the slides whenever I switch it from this mode to that mode. Okay, wait for 1 or 2 minutes, then it will be obviously visible. Now, once the task set has been defined, the next step is to choose the task for the software project, that which task is needs to be taken into the consideration, right? So we have various models. We have got the linear model, sequential model, iterative model, evolutionary model. We all know about these things. So now we are going to see how to choose the task for the development of the project. So first is your scope, means what will be the overall scope of the project that the company is going to develop. First thing that is being taken into consideration is the scope and the feasibility study. There is one term which is missing over here, which says that the feasibility study and the scope, means what will be the scope of the project, how it is going to be used, where it is going to be used, what will be the application, and whether the project that is being developed is feasible or not, whether it is worth developing or not, whether the team will be able to develop or not. So the feasibility study is being checked in all the points, or in all the important points. Second thing in choosing the task comes as the scheduling and planning. as we are able to understand it by the term only. What is scheduling and what is planning? Scheduling means which module is going to be created first. Planning is to plan the entire thing. What will be the team of the who will be the members of the team for the development of the project, who will be the members for the development, who will be the members for testing, who will be the members for the coding. So planning includes the overall planning. Scheduling is to prioritizing the task, right? And also mentioning about their various milestones, preparation of the weekly reports, etc. So that comes under the scheduling and the planning. Means before entering into the field, just have a proper schedule, just have a proper plan, right? After that, deciding what will be the hardware and the software that will be used for the development of this particular project, what will be the language that will be used for the coding part, all those hardwares and the softwares and the technologies which will be needed. Then after that, how the customer interaction is going to be performed. Customer interaction means, for example, you have developed a particular module, you just deliver it to the customer, and you're just now asking the feedback from the customer, and on the basis of the feedback from the customer, you are again modifying that particular module if the feedback is saying that all these are the points that are also required in this particular module. So third point or the fourth point is our customer interaction. Then after that, the constraints and the limitations. Obviously every team try to develop or try to meet all the customer specifications or all the requirement specification, but there are always certain kind of the limitations and the constraints which arises in a particular project, so they also needs to be taken into consideration. Then after that, we come on to the point of the risk assessment. So risk is always involved into the project. There is always a probability of occurrence of any of the problem. So accessing those probabilities of the occurrence of the problem is taken into the risk assessment factor. Just checking whether there is any particular kind of the thing that can happen or not. So that is being taken into our risk assessment thing. Then after that, we are coming on to the scheduling method. We are just treating the scheduling over here. What is the scheduling? So now we are going to see what is the scheduling and what are all the methods and the techniques that are being used into the schedule, that are being used for performing the scheduling, right? So the scheduling of the software project can be correlated to prioritizing the various tasks with respect to their cost, time, and the duration. As I have explained you, that scheduling means the prioritizing, means at this particular duration of the time, this task is important. At another particular duration of the time, that another task is important. So performing this important task of prioritizing various jobs is basically comes into the scheduling of the software project, and it considered the various factors, like it considered the factor of the cost, it considered the factor of the time and the duration also. Now what are all the techniques that are being used for performing the scheduling? They are as follows. The first one is our work breakdown structure. Work breakdown structure means there are basically two types of the work breakdown structure. Either the bottom up approach is followed or the top down approach is followed. The top down approach is basically you have, it looks like when can you able to see this moving cursor whenever I'm moving?
Yes, we see when you moving the pointer. Just in here you can point with pointer. That's no problem.
Okay.
Yeah.
Okay. So we were discussing about the work breakdown structure. Work breakdown means the work is what? The work is the development of the software project, right? Breakdown means how we are going to distribute that work into different parts, right? That comes under the work breakdown structure. Means you have got the work. Now there are two approaches to reach that particular project or to reach onto the final project. First is my bottom up approach, and second is my top down approach. So in the case of the top down approach, what is happening, that a tree like structure is being formed. We all can see it as a tree like structure where we have a root and then we have the various childs of that particular roots, or these are we have the various branches of that particular root, right? So what is coming into the top down structure? We have got the software project. Now this software project is being divided into the various branches. First, this is the branch that could be your requirement specification branch. Then we have the designing branch. Then we have the coding branch. Then we have the testing branch. And then we have the maintenance branch. Now, the requirement specification branch can also be divided further into various branches, that this much portion of this particular branch is going to be handled by this much portion is again handled
Sorry,
by.
mom.
Huh.
When you're moving the pointer, you can choose the freehand drawing. To the example is like this. We can, yes, with this you can use the freehand to explain as this is. I think this is good, and we catch something.
Okay. Okay. So I was explaining you this, right? So, for example, this first block is representing as the requirement specification, which is not written over here, but obviously it is the requirement specification part only, right? Then we have the design, then we have the coding branch, then we have the testing and the maintenance branch. We have broken down all these phases also into the several branch. We can see the arrows coming out from these particular phases also, right? Requirement specification, there are various arrows are coming down. Then the design, various arrows are coming down. It says these arrows are signifying that the design phase is again broken down into various tasks. Then design phase is broken down into, for example, the task D1, D2, D3 and D4. And when all the tasks D1, D2, D3 and D4 will be completed, then the entire design phase will be completed. Similarly, for example, coding part has also again got various branches. So C1, C2, C3 and C4 are the tasks into the coding phase. You completed all the tasks C1, C2, C3, C3, C4, then the coding phase is also going to be completed only. So that is what is also being, I think, written over here, that the project is split into the requirements and the analysis, design, coding, testing and the maintenance phase. Further, the requirement and analysis is divided into R1, R2, Rn. Design is divided into D1, D2, Dn. Coding is divided into C1, C2, Cn, and so on. The further subdivision is done. Upon the completion of each stage, the integration is being done. I think it is very much understood now. I have also explained you in the similar manner, which has been written, that it is basically the dividing your all the phases into another separate branches, right? These arrows are just showing you the divide, and it is basically the divide and conquer approach that you, I think, might also be studying into your algorithm part. You divide everything and then you just keep on joining, and ultimately your software project is being developed. So that is the entire, or that is the soul of this work breakdown structure. Moving on further, we have the another kind of the scheduling technique, which is our flow graph. What we are doing into the flow graph, we are just trying to create the we just try to first of all represent the modules with the help of the edges and the nodes. So these circles are your nodes. This is node M1, this is node M2, this is node M3, and then we have the node M4 and the last node, right? And these arrows are basically called as our edges. So what is happening in this case? M1 is our starting edge, and the data is flowing from M1 to M2 and M3. From M2, the data is going to M4. From M3 also, the data is going to M4. So basically, in the case of the flow graph, what we are trying to show, that how the nodes are being connected with each other and how the data is flowing among these nodes, right? It could also happen that from M2 the data does not go to the M4 node, right? So any of the possibility could happen. It is basically the representation in the form of the nodes and the edges, and there is always a starting node, there is always an ending node, and in between we just try to represent the flow of the data among the various modules inside our software project or inside any of the phase of our software development project. So that is happening into the case of the flow graph. Then we have another kind of the scheduling technique, which is called as a Gantt chart or the timeline chart. And this is also one of the important kind of the technique which is being followed generally, right? Gantt chart is, for example, if you wanted to write any project, uh, if you wanted to propose any project, then in that case also you have to draw a Gantt chart or the timeline chart. What a Gantt chart represent? Gantt chart basically represent, it has got various rows and columns, right? In the columns, first of all, we are just going to write about all the tasks, right? It has been written over here, you all can read it. Tasks are being written. This task is going to include the list of all the important tasks, or the majorly, uh, we can say that which module, name of the modules can be written over here. For example, the task 1 is there, A1 and A2 task is going to be performed, then B1 and B2 task is going to be performed, then C1 task is performed, and then D1 and D2 task is being performed. And what these rows are representing, these rows are representing you the duration of the time in which that particular task is going to be completed. So how we are going to read this entire Gantt chart? We are going to read it in this manner. For example, we have got A1 task, right? This A1 task is going to be start from the starting of the week 1, and it is going to be completed till the mid of the week 1 only, because we can see that the entire duration of the week 1 is from where to where, starting from this part, and it is going to complete it to this part, right? And from this time it is going to, week 2 is going to be starting, and here the week 2 is going to be completed, then week 3 is going to be start, and week 3 is going to be completed in this much amount of the time, then week 4 is. So we are seeing that the A1 task is going to be completed somewhere in the middle of your week 1 only. Then after the completion of the A1 task, the team is going to go to A2 task, and then from the time the A1 task is completed, the team will start working onto the A2 task, and this A2 task is going to be completed somewhere in the starting of the week 2. It's not just like that ki A2 task needs to be completed with the completion of the week 1. No, A2 task is going to reaches to the starting of the week 2. So this is how we divided the entire time duration. B1 task is going to start from the starting of the week 2 only, and then it is going to be completed in the, I'll just say, after the 3/4 of the week 2 is being passed. So this is how we represent the tasks and the time duration which are going to be taken in the completion of all these tasks. And then we also mentions the milestones, that after the completion of the A1 and A2 task, this is the milestone which is being achieved. And milestones are always mentioned onto the completion of the task only. A1 A2 task completed, milestones comes over here. B1 B2 task completed after the completion of the week 2, then we are going to mention about the milestones. Then after C1 task, then after the D1 and the D2 task completed. So in the Gantt chart, basically we break down our tasks into the various sets, and then we also mention that this is the probable duration in which this task is going to be completed, and this is going to be the milestone that would be achieved after the completion of this particular task. Then we have the program evaluation review technique. Program evaluation review technique is basically used for the high risk project with various estimation parameters. For each module in a project, duration is estimated as follows. First is time taken to complete a project or the module under the normal condition, represented by T normal. Then time taken to complete a project module with minimum time. This is represented with T minimum. Then time taken to complete a project or module with the maximum time. This is represented with T maximum. And the time taken to complete a project from previous related history, that will be mentioned by making the use of the term T history. So in the case of the program evaluation review technique, we basically, this technique is being used for the high risk project, right? And then the various estimation parameters related to the duration of the estimated time is taken into consideration. It could be T normal, it could be T minimum, it could be T maximum, or the T history. T normal means time taken to complete a project under the normal conditions. Then T minimum means minimum amount of the time in which the that particular project or the module is going to be completed. T maximum means maximum amount of the time required for the completion of that particular project. Then time T history is basically related to the previous related history which is being available into the particular organization, that is being taken into consideration into the T history parameter, right? Then after that we are going to go and talk about the software project plan. What is the software project plan, how the entire plan looks like? So the software project plan, it looks like this. These are all the important points that are being taken into consideration for the software project plan. So what we have, obviously it is planning a particular project is the responsibility of any software manager only, right? So the what the good managers do, the good managers first of all carefully monitors the development at the various phases. Improper planning leads to the failure of the project and which no company needs. Now software project plan, we can just view it as with a perspective of both. How, what is a software project plan with the perspective of an organization, and what is a software project plan with the perspective of the customer? So with the perspective of the organization, it is like how the project is to be implemented is the first question into the software project plan. Next question means what are the various constraints in the form of the time, in the form of the cost, the number of staffs that are being available, and what will be the market strategy for that particular software project. Now, with respect to the customer, what will happen? Now, weekly, the important thing that is being taken into the consideration of the software project plan is to conduct the weekly or the timely meetings with the customer with the presentation of the status report, that this is the current status of the particular project, right? So status project is being communicated to the customer, and then after that the feedback of the customer is taken into the consideration in the case of the whenever you are planning the software project. Now for a successful software project plan, the following steps can be followed. So these are all the steps. I'm just going to read them. They are very much understandable, that is why they are just being written into the points only. First thing is to select a project. And what are all the criteria that comes into the selection of the project? The first is identifying the project aim and the objective, right? If the customer is coming to a particular organization, then what is in the head of the organization, whether to select a project or whether to not select a project. And for selecting the project, the factors which the organization takes into consideration is to see and identify what are all the targets that the organization needs to achieve, what is the objective of that particular project. Then second thing is to understand the requirements and the specifications that are always being provided by the customer only. Third is to what are all the method of analysis, design, and the implementation. Then testing techniques that will be used and the entire documentation that is going to be performed. After that, the second point that comes into the project planning, or second point that is important for the successful software project, is the milestones and the deliverables of your software project. That what are all, how is the milestones means, how is the quality of, generally how is the quality of that product, right? And how that product is going to be created into that particular duration of the time. So if that particular in the particular duration of the time the product is being formed, then that is also being considered as a milestone. What are all the testing strategies that are being applied to test the software project is again a kind of the milestones, and how is the quality of the product is another form of the milestone only, right? So successful software project always consider the project milestones and the deliverables. Now the next important point is always like the cost factor. So how the budget allocation is being done, exceeding the limits or within the control, right? Then after that, project estimates. Whenever we are talking about the estimation, we are always talks about what we have covered all these points, we have studied about all these points. It is always about the cost, time, size of the code, and also about the duration. Then resource allocation, what are all the resources that will be required, the hardwares, the softwares, the previous relevant project information, and the digital library. Then Obviously, the risk management needs to be taken into the consideration. It includes the avoidance of your risk, the detection of your risk, the control of your risk, and the recovery of your risk. Then after that, the scheduling techniques. We have just covered all these scheduling techniques: the work breakdown structure, the activity graph, critical path method, Gantt chart, program evaluation review technique, and many more are also available, which comes under the scheduling technique. Then people means what are all the staff, whether it is available or it needs to be recruited freshly, team management, and the customer interaction. And the last point is our quality control and the standards, right? So all of the above methods or the techniques are not covered in this unit, and the student in that is the another thing which you need to study, right? So these are all the important points, and most of these points we have taken into consideration. Most of them have been discussed, and all these points have become very very important whenever the aim is to deliver a successful software project, right? So these are all the important steps in detail, and what comes under which step is also being mentioned over here. So you need to take a look of all these steps, and you need to just understand about all these steps. So this was the last point inside the unit risk management and the project scheduling, right? So we have covered all the points in this particular unit, and it's started into the last class only. So we have covered about the introductions, objectives, identification of the software risk, what is the software risk, monitoring of the risk, management of your risk, then controlling the risk, risk recovery, and so on. All the points that we have covered today. I think this chapter of this unit is clear to you all.
Yes, ma'am.
Okay. So after completing this particular unit, we are just going to go and start with the another unit, which will be called as, just a second. So next unit will be our testing unit. We should be able to learn and remember and revise that we have covered the requirement test specification part, right? We have covered the designing part, coding part we don't have to actually consider, but everything which are being needed to know, all those things we have learned till now. Now we are going to move on to our testing part. So if we are reaching on to the testing part, it means now we need to imagine that our software is coded till now, right? Now we have the various modules that are being actually coded, and now the next task that comes into the picture is to test those modules, is to test the code, is to test those programs that have been written by the coding team, right? Or is to test the entire software that is being created. So we are going to just start with this part, right? This is the software testing unit. It has got a number of the objectives for all of us. We have to understand what is testing, what is black box testing, what is white box testing. Then we also need to learn about what are all the testing activities, right? Different types of testing: unit testing, integration testing, system testing, and what are all the techniques that comes under all these particular testing techniques. So first of all, we have to understand what is testing and what is the objective of the testing, right? So first of all, testing means if a particular project or if a particular software is being developed, then it's the responsibility of the testing team to find out the errors in that particular software, right? Testing is not for just is never performed with the purpose of not finding the errors. Testing is always performed for finding the failures, for finding the errors, and for finding the problems in that particular software or in that particular module that is being tested at that particular time. So testing means executing a program in order to understand its behavior, that is whether or not the program exhibits a failure, its response time or throughput for certain data sets, its mean time to failure, or the speed and the accuracy. So these are all the important points where the failure can occur. The failure can occur in the case of whether the software project is behaving in the similar manner as it should behave, right? Second, failure can occur into the case of the response time. Failure can occur into the case of the throughput. Failure can occur into the case of the mean time or the speed or the accuracy. If any of these point is not proper, then the software will not be delivered. It will be considered as the problematic software. It would be considered as a software which is not fulfilling all the requirements. It will be considered as, means there is a need to revise that particular software. So basically in the testing phase, the important thing which needs to be considered is to find out the problems, is need to find out the failures into the project, right? Next is Next is we need to understand about two important terms. One is our validation and second one is our verification. Validation means to check, are we building the correct system? Whatever the software we are developing, whether we are building the correct system or whether we are building the correct software or not. Verification means, are we building the system correctly? Means whatever the process we are applying on building that particular software is correct or not. So verification mainly focuses on to the process part, means the process, the steps that we are following in implementing that particular software project is correct or not. Validation mainly focuses on to the entire software, means the software that we are building is correct or not. That comes under the validation and the verification part, and these are the two very important things that always being considered into the testing. We validate the software and then we verify the software also, right? So two important parameters that needs to be considered in our testing is our validation and the verification. To repeat it again, to make it more clear, again I'm saying validation means building the correct system and verification means whether we are building the system correctly. That comes under the verification, whether we are building the system correctly, right? Then there are various components that needs to be taken into consideration whenever we are performing the software testing, right? So correctness of the various things needs to be in the head of the testing team. What are all that? First is the correctness of the software with respect to the requirement or the intent, right? For this purpose, the testing is being performed. What this line is saying, this line is saying to us that whatever be the intent, whatever be the requirements, whatever be the specification of the customer, the software that has been developed is correct to all those requirements or not. The software that has been developed is able to perform all those requirements that have been specified, is able to meet all those requirements or not, right? That comes under the correctness of the software. Now the performance of the software under various conditions is also being tested. So all these points are what? All these points are telling us for which factors the testing or the software testing is being performed. All these points are telling us that, right? So for the purpose of checking the correctness of the software, the testing is performed. For the purpose of checking the performance of the software under the various conditions, again the testing is being performed. For the purpose of checking the robustness of the software, whether it is able to handle the erroneous situations or not, again the testing is being performed. For the purpose of checking out the usability of the software under the various conditions, whether the software is useful or not, whether it is usable or not, again the testing is being performed. For the purpose of checking the reliability, availability, survivability, and the various kind of the dependability onto the various kind of the measures, the software testing is being performed. Then the installability and another facets of the software that are being released, or to all those things also the software testing is being performed. So the major purpose of the testing is to show that the program has the error, right? So just imagine the testers are always enter into the testing phase with the mindset that they have to find out the error. And the above points, all these points which have been highlighted, they are all saying that for what purpose the testing is being performed. So the testing is being performed for the purpose of finding the correctness of the software. It is also being performed for the checking out the performance of the software, to test whether the software is robust or not, to see the usability of the software, to find out the reliability, availability, survivability, and the dependability of the particular software, and again for the installability and the another facets of the software. Next is the purpose or the aim of your software testing is to find out the errors in your program and to locate the faults into the program and then repair them, right? We always, what we do whenever we create anything, whenever we develop a project, we always try to test it. After the testing, if there are no error, then only the development team got the confidence that okay, we have developed a good and the correct software, because we have made this project to go through the testing phase and it doesn't have any kind of the errors, it doesn't have any kind of fault that is being pointed by the testing team. Now we have the confidence that we have developed a correct project or we have developed a correct product. So from where the organization is getting that confidence, the organization is getting that confidence from the testing team only. When the testing team passes the software, then only the organization felt that okay, the software is correct. If the testing team is able to locate the various faults into the program, then obviously there is always this goes to the coding part, or this goes to the team in which the fault has been detected. So that particular team, whether it is related to the designing team, whether it is related to the coding team or the development team or any of the team, then it has become the responsibility of that particular team to remove all those bugs, or to remove all those faults that are being pointed by the testing team, right? Then we have the another term which is called as the debugging. So testing and debugging are the two different things. Debugging is basically the activity that is being divided into two parts. The first function of the debugging team is to determine the exact nature and location of that particular error, and then after locating the error, the next function of the debugging comes as fixing that particular error, right? The testing team is just to find out the faults, right? Debugging means find out the fault, find out the exact nature and the location of that particular fault, and then fix that error. That comes into our debugging part, which we are going to discuss later on in this unit. So what it says that the purpose of debugging is to locate the error and then fix them. But before going on to the debugging, we have to just see what is the testing and how many types of testings are there. We need to understand that, right? So these are all some of the basic terms that we are going to use into this unit. First is the failure and what we understood by the failure. So failure means failure occurs whenever the desired objectives are not being achieved, right? The project or the module is performing into some another direction which was not desired. So there is a deviation of the observed behavior from its specification. Then we say that there is a certain kind of the failure into this particular module because it is not fulfilling the desired specifications, right? If it is not performing according to the desired specification, then we say that, then we make use of the term failure. Then fault. Fault means if there is an incorrect step, there is an incorrect process, or there is an incorrectness into the definition of the data, then we say that there is a certain kind of the fault. Then we make use of the term software faults, right? Like an incorrect step is being performed or an incorrect process is present into our software coding part, then the term that is going to be used is called as a fault term. Error means the difference between a computed, observed, or the measured value or condition and the true specified or the theoretically correct value or the condition, right? Error means there is a computed value, there is an observed value, or there is a value that is being computed and which is absolutely different from the value that is being specified, or which is absolutely wrong. Whenever a wrong value is being computed, then we say that an error has occurred. Now, the next very important term is our test cases. So what is the test cases? Test cases means a set of the test inputs, right? Means test case means we wanted to test our software, right? So we need to give certain input to the software and we need to check how the software is behaving whenever we are providing those inputs to that particular software. So this set of the inputs are called as the test cases. it is also being mentioned over here. If you can see where this pointer is moving, test cases are basically the set of test input. The expected results when the inputs are executed, and the execution conditions or environment in which the inputs are to be executed. So test cases generally includes all the situations, all the conditions. So we try to make the type of the test input so that they are able to test the software in all the possible situations and all the possible conditions that that can arises in a particular software. So test cases means set of test input. Just remember that test case means there is a particular set which includes a number of the inputs, and these inputs are going to be fed into our system, and then we are going to see how the system is behaving for these particular inputs. So that is our test cases, right? Then what we have, there are certain testing laws. Then we have just a second. Then we have the black box and the white box test case selection strategy. And what is the black box and the white box testing? We need to understand about that. So testing laws are basically testing can only be used to show the presence of the error, but never the absence of the error. I have explained to you that what is the purpose of the testing? The purpose of the testing is to find out the error, right? We just enter into the testing phase with an aim to show the presence of the error. And it is never like we are aiming to show that there is no error, because always there is going to be some error. So the purpose is to find out those errors. Now, if the combination of the different verification and the validation methods outperform any single method alone, developers are unsuited to test their own code. So all these are basically the various laws that are being performed into the testing. Now, the important point for all of us to understand is the types of the testing, right? So for that, I will be sharing a Word document with you all. Just a second. Yes. You all can see this Word document?
Yes, ma'am.
Yes.
So now we are going to discuss about the type of the testing. Majorly, the software testing is classified into two categories, and these are like very, very important. If anybody is talking to you and asking you about the testing of the software, then obviously you have to know about the black box testing and you have to know about the white box testing also. So in the case of the black box testing, I'll just try to make you understand in the layman language what happens in the case of the black box testing. Means now you are testing the software with the purpose of checking the functionality of the software. Means how my software is performing its function, that comes under the black box testing. White box testing means it is just going to check each and every implementation details of that particular software. Means how the particular coding is being done, whether there are any errors into the code or not. Black box testing is going to check whether there are error in the functionality of the software. Means black box testing consider the outer perspective of any software. It just check whether the software is functioning into the manner in which it should function. It is just matching the desired specifications. It is functioning according to the desired specification or not. That is checked into the black box testing, right? Only the external design and structure are being tested in the case of the black box testing. Whereas in the case of the white box testing, the internal structure, the design, the implementation, the code, everything is being tested. Right? I'll just read these two lines for you. What it says in the case of the black box testing, it is a software testing method in which the internal structure, the design, the implementation of the item being tested is not known to the tester. The tester is not going to know what are all the internal structure, but he is not even concerned about all these things. What he is concerned about? He is concerned about the external design. He is concerned about how the software looks like, how uh, the implementation of the software is, how the structure of the software is. So he tests all these things. Whereas in the case of the white box testing, it is a software testing method in which the internal structure, the design and implementation, all these things are taken into the consideration. In the case of the black box testing, it is a testing technique in which the internal working of the software is not known to the tester. It is again a very, very important line. I'll just highlight it, that the internal working of the software is not known to the tester. Whereas in the case of the white box testing, it is always known. The tester, in the case of black box testing, the tester only focuses on the input and output of the software. That is what I've explained you, that he always concentrate onto the functionality or the functional requirement of that particular software. And how the functionality of the software will be tested: when a particular input is fed it into the software, and then the output of that input will be checked whether the output is cordial with the input or not, or is in accordance with the input or not. That is the black box testing. White box testing is a testing technique in which the tester has got the knowledge of the internal working of the software also, and can test the individual codes, the snippets, algorithms, and the methods. Now, whenever the tester has got the knowledge of all the internal functioning of the software, means you can consider it like that. Whenever we are talking about the front end of any software, then the black box testing is being done. Whenever we are talking about the back end of the software, then the white box testing is being done. So whenever the tester knows about all the internal details of any particular software, about the individual codes, about any snippets, about all the algorithms and the methods that are being used for the development of that particular software, then when all these things are being tested and when all these things are being checked, then it comes into the category of your white box testing. Now, what is the objective of the testing in the case of the black box? The objective of the testing is to test the functionality of the software, ensuring that it meets the requirements in the specification, right? This is being explained many times. Now, white box testing is mainly focuses on ensuring that the internal system or the internal code of the software is correct and it is also efficient. Because when the internal code is going to be correct and efficient, then obviously there are better chances that in the case of the black box testing, the software just passes that particular test. So white box testing is also very, very important because it checks the internal code of the software, and it checks onto everything about the algorithms, about the methods, about the procedures, whatever being used for the development of that particular software internally. So that is being taken into consideration in the case of the white box testing. Now, the knowledge level in the case of the black box testing is, it does not require any knowledge of the internal working of the software. Obviously, when the internal working is not being taken into consideration, so it is not necessary that the tester should have the internal working of the software also. No, he just needs to know about how the particular software should perform. Whereas in the case of the white box testing, knowledge of the programming languages, software architecture, design patterns, everything needs to be there inside the testers. So what we say, the knowledge level in the case of the white box testers are like better in as compared to the black box testing. So another important points which are about the white box and the black box testing are, white box testing are easy to use, as we have seen also, because it is just going to consider about the input and the output of any particular software. It requires no programming knowledge and is also effective in detecting the functional issues. If there is any functional issues, means the software is not performing the function as it should perform, then obviously the black box text tester is going to mention that. However, it may miss some important internal defects and that are not related to the functionality. Yes, it is the possibility, because as black box testing is not considered with the internal functionality, so it can miss out some of the important effects, right? Whereas in the case of the white box testing, it is effective in detecting the internal defects and ensures that the code is efficient and it is also maintainable. And it always requires the programming knowledge and can also be very time consuming. So in conclusion, both the black box testing and the white box testing are important for the software testing, and the choice of the approach depends on the testing objectives, testing stage, and the available resources. So now it is the ball is always in the court of the organization, whether they wanted to perform the black box or the white box testing, or they just wanted to go with both the testing, because both the testing has got its their own advantages. One is considered to be a little better than the another, which is like white box is a little better than the chances of finding the errors in the case of the white box is better as compared to the black box testing. But sometimes it all it like happens, and it always depends on to the organization that it goes with the black box testing according to the various measures or the factors which are present in that particular organizations. Right. Now we have the various designing techniques. First is a black box test design technique, and then we have the white box test design technique. So there are majorly two test design techniques in the case of the black box testing. One is my boundary value analysis, and the another one is my equivalence partitioning analysis. One is BVA, another is my equivalence partitioning analysis technique. So what is this boundary value analysis and what is this equivalence partitioning analysis technique? So boundary value analysis is basically the black box test design technique, which is used to find the errors at the boundaries of the input domain. So what is considered into the boundary value analysis? Now we can check it from the name only, that we try to find out the errors at the boundary of the input domain. Now what we understand by the term boundary, we understand that we try to locate the errors in the extreme ranges of the in the extremes of any particular range. We are just going to understand it with the help of an example. Now suppose if there is a set of the input values between A and B. Now if the boundary values are going to be this, we have got the input A and input B, right? The boundary values will be first A plus 1, which is one value greater than A, then one value lesser than A. So boundary value of A will be, we have got the mid range as A, one value greater than A and one value less than A. They will be considered as the boundary values for A. Then similarly in the case of B, we have got the mid value as B, one value greater than B and one value less than B will be coming into our B values, right? So what we do in the case of the boundary value analysis, we just try to focus on finding out the errors that at the boundaries of the input domain. We are giving a particular input to the software, and then we just try to give the boundary values of that particular input. For example, we have got the age, right? Example is age. Now it accepts the constraint is what? It accepts any value from 18 to 56, right? We can enter the age from the age 18 to age 56. Now how the boundary value analysis test case is going to be? Now age is from 18 to 56. I'll just minus 1 from 18. What it would be? Minimum minus 1. First invalid value will be minimum minus 1. So what is minimum among 18 and 56? It is 18. So 18 minus 1 will be 17. Valid values will be what? Valid is the minimum value. What is the minimum value? 18 plus minimum value plus of the minimum value means one value more than 18. That is going to be 19. One value less than maximum value. What is the maximum value? 56. One less than 56 is my 55. One value more than one value exact as the maximum value, which is going to be my 56. Another invalid test case would be maximum plus 1. So what is maximum value? Maximum is 56 plus 1 will be 57. So we will have two invalid values, which are going to be my one value less than the minimum, which is going to be my 17, and one value more than the maximum, which is going to be my 57. And all the values which are just falling in between, which is going to be minimum plus minimum, maximum and minus maximum, and they are going to be my valid value. So how the test case is being performed, how this black box testing is going to be performed, why we take these invalid values also? Because we wanted to check whether my system is giving the correct answer in these cases or not. For the invalid, if I'm putting an invalid value, then my software is giving me the correct answer or not, whether it is showing me that it is the invalid value or not. right? So that is happening in the case of my boundary value analysis. I just take the boundary values of my minimum and the maximum value, and then I'll just put all those invalid values, and I'll check whether the software is responding that the values you have entered is invalid, or whether the software is responding for the invalid value also, that the value you have entered is correct. So if the software is responding into the wrong manner, then we can, or the tester can say that this module is not correct, because obviously we have to put the wrong value to check whether the software is performing correctly or not. And in the case of the boundary value analysis, we choose those wrong values with the help of the boundary value analysis by just taking the boundary values of the minimum and the maximum. I think it's quite easy. Have you understood this?
Yes, ma'am, it is easy.
Yeah, it's, this example is very easy. Even if you haven't understood all these theory, by just reading this example, it is going to be clear, right? Now we are going to move on to the next technique, which is my equivalence partitioning technique. So what is equivalence partitioning? Now equivalence means there is something which is going to be equal, right? Partitioning means we are dividing. So in the case of the equivalence partitioning, we are making the equal classes. We are dividing the data into the set of the equal classes, and then we are just checking those equal classes whether this class is equal or not, whether this class is valid or not, right? So how we are performing? First of all, we are dividing our data into the various equal classes. So I think it is also being written over here. In this method, the input domain data is divided into the different equivalence data classes, which are generally termed as valid or invalid. We are also going to understand it with the help of an example also. And the input to the software or the system are divided into the groups that are expected to exhibit the similar behavior, right? Thus, it reduces the number of the test cases to a finite list of the testable test case, covering the maximum possibility. We are just going to see an example. Yes, this example we are going to see. What this example is saying, it is saying that we are considering an example of any college admission process, right? There is a college admission process, and there is a college that gives the admission to the student based upon their percentage, right? Consider the percentage field that will accept the percentage only between the 50 to 90%. More and even less than not be accepted. Means if the student is falling into the range from 50 to 90%, then only he will be able to get the admission. In the situation, if he's getting his marks more than 90%, then also he will not be getting the admission. And if he's getting his percentage as less than the 50%, then again he will not be taking the admission, or he will not be getting the admission, and the application will be redirect user to an error page. If the percentage entered by the user is less than 50% or more than 90%, that equivalence partitioning method will show an invalid percentage. If the percentage entered is between 50 to 90%, then equivalence partitioning method will show the valid percentage. So how this is happening? This is happening like this. There is a percentage. Now it is showing that it accepts the percentage value between the 50 to 90%. This is the condition. Now equivalence partitioning is doing what? It is dividing the data into the valid and the invalid category. Invalid classes are going to come into this column. Valid set of the percentage is going to come into this column, and the invalid is again going to this column. What this invalid is showing? This invalid is showing that the percentage is less than or equals to 50%. What the another invalid is showing to us? It is showing to us that the percentage is greater than or equals to 90%. But the valid classes will be come into this category. So how all the data is going to be set? All the data is going to be set according to this criteria and according to these classes. Now the student who have their percentage between 50 to 90, they're going to come into the valid class, and another set of the data which doesn't fall into the valid class is going to either go to the first invalid class or to the third invalid class. So this is how we divide the entire data set into the valid and the invalid classes. That is why we say that there is the equivalence partitioning of the data.
Excuse me, ma'am, it is almost like boundary.
Yes, it is almost like the boundary value analysis, but in the case of the boundary value analysis, we are just focusing on to the one value minimum, value maximum. It is not happening into this case that we are considering one value minimum and one value maximum. We are not saying that one value maximum to this 50 is going to come into the another category or the invalid category. The important point in the case of the boundary value analysis is this part when we say that this na a plus 1, a minus 1. So we are just taking the range. We are taking a mid value going one above this and one less than this. It is not happening into the equivalence partitioning case. It is just considering the case of dividing the entire thing into the different classes. Here we are forming the set of the class. There we are not forming the set of the any class. We are just taking the values in the set of the ranges, +1 and -1 range. So that is the major difference in both the things. Moving on. Now, there are various white box testing strategies and there are various black box testing strategies which are available to us. So in the case of the white box testing strategies, there are three methods by which the white box testing can be performed. First is my coverage based testing, second is my cyclomatic based testing, and the third is my mutation testing, right? So we are going to cover all these important kind of the testing. I hope you are clear with the white box and the black box testing. You just tell me, any of you can tell me about what you understood by the white box testing.
White box
In
is
black
only
box,
focusing on the.
One by one.
Okay, go ahead, man. Go ahead. Go ahead.
in black box testings, the tester doesn't know about the implementation, internal structure, or any algorithm. And in white box, the tester have knowledge of all these things. So that's the main difference between these two.
Yes. Anyone else who would like to tell?
Yeah, that's just like front end designer and back end designer, like the black
Yes.
box.
Yes.
Tester is considering everything in the front end.
Hmm.
So the white box is considering everything in the back end, which is implemented.
Right.
Putting code.
So you have understood about the white box and the black box testing, right? After that, we are going to now see what are all the strategies that are being followed in the case of the white box testing. White box testing means now we are considering the internal structure of the software, right? We are just focusing on to the internal structure means we are checking the codes, algorithms, methods, processes, whatever it is. So all these strategies can be used. First is my coverage based testing, second is my cyclomatic complexity, and the third is my mutation testing. Coverage based testing means we choose the test cases to exercise. Coverage means we wanted to cover the entire thing as much as we will be able to cover, whether we are covering the statements that have been written, we are covering the decision coverage, or we are conditions that have been applied, or the path that has been followed. So these are the four important things that are being considered in the coverage based testing, and it is also being mentioned over here. Coverage based testing works by choosing the test cases according to the well defined criteria, and the common coverage criteria are the coverage of which criteria are taken into consideration. They are as follows. First is the statement coverage or the node coverage. It says that whenever the white box testing is being performed, whether the every statement of the program is covered in the white box testing or not, that comes under the statement coverage. It is also saying that every statement of the program should be exercised at least once. It should be covered at least once. So in the case of the coverage based testing, and inside that statement coverage or the node coverage means whatever be the statement which is present in the internal functioning of that particular software, at least one time that particular statement needs to be focused on. There should be at least a single time when that particular statement is being covered. Then we have the branch coverage or the decision coverage. So in this case, every possible alternative in a branch or the decision of the program should be exercised at least once. Branch or the decision coverage means we have got the various decision statements in our C language, for example, in any of the programming language. For example, we have the if statement, or we have the if else statement, or we have the else if statement. So whenever this kind of the branching is being performed, then at least there should be one time when each and every possibility of that particular branch is taken into consideration or is exercised at least once. Decision or the condition coverage means whatever be the conditions that have been present into your code, then that condition should also be covered at least once. Condition could be in the form of the true or the false. So the in at the time of the white box testing, there should be an input test case which is checking that particular condition for the true condition and which is also checking for the false condition. Path coverage means every execution path of the program should be exercised at least once. At least once, एक बार every execution path means if there are various execution path, then all the execution paths should be exercised, should be checked at least once. So coverage based testing means it is try to cover all the important parts. It is try to cover all the statements, all the decisions, all the branch coverage means whatever being present inside that particular coding part or the functioning part or that particular programming part, it should be covered at least once. It should be covered means it should be checked at least once, right? So that is coming into my coverage based testing. Then I have my mutation testing. In the case of the mutation testing, I will say that it is a very powerful tool for finding the errors into the software. Mutation means to create the multiple copies of a particular program. Mutation means you just create the copy, you just clone your software program. You have a program, you make the copy of your program. So that is basically comes under the mutation testing. And after creating the various copies or the alternate copies, then the testing is being performed onto those particular copies or onto those particular clones that have been created. So in the case of the mutation testing, the word mutation means creating the copies or creating the multiple copies, and then these multiple copies are going through the various or different kinds of the test cases. Whenever all these copies passes the different types of the test cases, then they are being again merged into one, and then it is comes under the mutation testing strategy. In the case of the cyclomatic complexity, a control flow graph is being created. In the case of the control flow graph, it is basically a kind of the flow chart, means how the program is being, how the process is being performed. It is going from one set to the another set to the another set. Then we just calculate the complexity of those particular graphs, and then we say that whether it is highly complex or it is average complex or it is low complex or the your complexity is perfect. So that is basically coming into your cyclomatic complexity part. After that, there are various kind of the testing activities that are present for us. Means whenever the testing team is doing any kind of it is performing something, then these are all the activities that the testing team needs to perform. First is my requirement analysis. So testing should begin in the requirement phase of the software development lifecycle. So you should understand this thing that if we are talking about the testing, it is not started by the testing phase only. That it is never happened like only the code part of the software development lifecycle or only the code part of your software is being tested. No, testing always begins in the requirement phase of the software development lifecycle. This is very simple, very easy line to understand, that it started into the requirement analysis phase only. Then for the second activity, we have got the design analysis. During the design phase, the testers work with the developers in determining what aspects of the design are testable and under what parameters should the testers work. Now, inside the design analysis phase also the testing is being performed, and here the testers, they work with the developers and they check and they determine which part of the design should be tested and which part of the design should not be tested. So this decision is being made into the design analysis phase. If there is any particular phase or if there is any particular part of the design which should be tested, then it is being determined, and then that particular phase or that particular part is being tested into the design analysis phase. Then the test planning. Test planning mainly includes the strategy of the testing and what are all the test plans that will be used for the testing. So test planning majorly have two things: test strategy and the test plans. Test strategy means what will be the planning or what will be the route that will be followed in performing the testing. right? That comes under the test strategy. Test planning means what are all the test cases and how the test entire testing is going to be performed onto the software. That comes under your test planning. Then for the test development, we have got the test procedures, test scenario. Test development means to developing the various parts that are going to be used for the testing, actually performing the testing. That is going to include my test procedures, test scenarios, test cases, test scripts, and which are going to be used into my testing software. So for testing purpose also, we make use of a software only. You want to say something?
Nothing, Mom.
Yeah.
Sorry, I have a question, Mom.
Yes.
In here, we miss some lecture. Like in here, we have some examples and simple program for white box testing. It has a 2, 3, 4 example and also control follow graph. In here, I have a 1, 2, 3, 4 examples.
Yes.
This is good. You explain to us, and we catch something. Uh,
Yeah. So what we are going to do for that, you just go through with them, okay? First of all, because I've explained you about what the meaning of both the testings are there, and I'm going to take them into the next lecture only. Right. Today we are just going to complete the theoretical part. First of all, we must understand now what this testing is. Then only we can explain the examples. Right? So
right.
my approach is to make you understand before about all the types of the testing, that this is this testing, we consider this thing in this testing. So after going through all these approaches, then we are going to take the examples also. Okay.
Good, good.
So before
And
we,
please
yes.
explain little clearly, so we can't catch some words because we not know more English. Sometime we can't catch something.
So you know Hindi? I can talk in Hindi also.
Yes, yes. No problem. You can speak English, but sometime little
Hmm.
some important issue must be speak clearly little to catch
Okay.
it. Yeah.
Okay, okay. You can let me know whenever you don't understand any word.
Okay. Thank you.
Okay.
Go ahead. Sure.
So we were talking about the testing activities, right? So here also we were on to the development of the test. So what is coming into the test development, that obviously we must understand first of all that the testings are also being performed with the help of the softwares only, right? So we do have the testing softwares, and with the help of those softwares we just test the another software that is being developed, that could be for any of the purpose, right? So in the case of the test development, we just develop the test procedures, we develop the test scenarios or the situations that are going to be tested, then what are all will be the test cases and the test scripts. Then the next activity into my testing that is being coming is my test execution. Test execution means the testers execute the softwares based on the plans and the tests and the reports any error found to the development team. Text execution, as we can understand it by the term also, that what will be happening in this particular activity is to actually performing the testing. That is my test execution. Now at this particular point of the text execution means just perform the testing of the software based on to the plans that are being developed into my test development phase, and then report if any error has occurred into that particular uh, code or into that particular program. So in the case of the test execution, actually the testing is being performed. Now next is my test reporting. Whenever the test is being performed, then there is a requirement of the preparation of a report which is going to emphasize on to the various errors that has been found out, various mistakes, various faults, various failures, whatever, right? Whatever be the output, all those things needs to be reported, and that particular report is majorly called as the test report, and then that report is being delivered to the particular team or to the particular person in which phase that particular error is being found out. After that, retesting the defects. Now what will happen, the team is going to eradicate the particular problem that has been mentioned by the testing team, and then the retesting is being performed. That again, it has been checked that after the team has committed that these particular errors is being removed, then again the retesting is being performed in order to check whether that particular defect is being removed or not. So that is basically happening into the testing activities. So testing is not just going like that and start testing. No, it also includes a number of the activities. First of all, the requirement analysis phase in which the testing is being performed. Then it has also been mentioned that the design analysis phase also determine in which phase of the designing the testing can be performed, and in which phase it is not being performed. Then the test planning, which includes the planning of the test and forming a strategy for the testing. Then the development of the test, it includes development of the test procedures, test scenarios, test cases, and the test scripts. Then after that, test execution means now the test is being happening. The next activity, reporting whatever the error has been found out, just make a final report and deliver that report to the particular software teams. Then after that, team is going to resolve all the errors and the retesting of the defects is being performed. Now the defects are once again tested to find out whether they got eliminated or not. It is not just like the team is going to believe if the another team is going, the team is again going to test particularly whether all the defects have been removed or not. Now these are all the activities. Next thing that we have to see, there are various levels of the testing through which the software has to go. Now 3 types of the testing that we are going to see. One is my unit testing, then my integration testing, and the another one is my system testing. So broadly, the testing is being first of all divided into 2 categories, the white box testing and the black box testing. After that, the 3 levels of the testing are being formed. First is my unit level testing. Onto the 3 levels the testing is being performed: unit testing, integration testing, and the third is my system testing. So now we are going to learn about these testing techniques also. What is the unit testing, what is the integration testing, and what is my system testing. So what is coming into the case of the unit testing? The unit means we are going to test the parts of the software. We are just going to focuses on to the different, just the modules of the software. When we are testing a module of the software, then we say that we are doing the unit testing. Or if we are just testing a particular procedure of any particular software, then we are saying that we are performing the unit testing. It is a procedure that is used to verify that a particular segment of the source code is working properly or not. That means it is majorly focusing on to the parts of the source code. Means unit means we are just focusing on to a certain chunk. We are just focusing on to a certain part. A unit that could be a part of the source code also, that could be considered as a single module also, right? It depends on to the how much part we are taking, because module is again a part of the software only, right? Similarly, a part of the or a segment of the code is again a part of the software only. So unit testing can be performed onto the segment level, right? Whenever we are performing the testing onto the segment level, then it is going to be called as my unit testing. And the goal of the unit testing is to just separate each part of the program and show that the individual parts are correct, right? Now we are testing separately, individually, unit wise, means it is the least portion of the fragmentation of the entire software. If you just try to imagine that you have divided your software into the various parts, right? You have fragmented it. The smallest part will be called as the unit. And now your goal is to test that unit, and you wanted to check whether that particular part of your software or the smallest of the part of your software is performing correctly or not, or the individual part of the software is performing correctly or not. Then in that case, whenever you wanted to perform the testing on the individual basis or on the individual part of any particular software, then which kind of the testing you are going to make use of, then you have to decide that you are going to make use of the unit testing, right? So it also depends on to the requirements that which kind of the testing needs to be performed. Unit testing means you are performing the testing onto a particular part. Then that will be called as my unit testing. Then after that, we are going to talk about the integration testing. Integration means to combining. The word integration means to join, right? Whenever in the case of the integration technique, in this, the testing in which the individual software modules are combined and tested as a group, right? Integration testing means we are just combining the modules. We are just collecting the modules together, and now we are performing the testing onto those modules, right? What we know that whenever we develop the software in the form of the modules, obviously we those modules have to perform together, then only the entire project will be called as a software project, right? Similarly, in the case of the testing, we can perform the testing onto the single module also. We can perform the testing after combining the modules also, right? And when we perform the testing after combining the modules, for example, I'm performing the testing onto the module 1 and module 2, whether these two modules are working in synchronization or not, right? So whenever I perform this kind of the testing, then I'll be saying that I am performing the integration testing, right? What I've said, whether the module 1 and module 2 are performing in the synchronization or not, then if they're performing, then when this kind of the testing is being performed after combining the modules, then that testing will be called as the integration testing, right? It follows the unit testing and precedes the system testing. Integration testing takes as its input modules that have been checked out by the unit testing, groups them in larger aggregates, applies the test, defines an integration test plan to those aggregates, and delivers as its output the integrated system, or the integrated output is being delivered, right? I think integration testing is clear now. Unit testing performs the testing onto the chunks, onto the segments, right? Integration testing just combines or just club the modules together and then performs the testing onto that group of the module. Whenever we perform the testing onto the group of the modules, after aggregating them together, after combining them together, after clubbing them together, then that testing is called as my integration testing. Moving on, we have to see now what is the system testing. Now system testing, as the name indicates, is the overall testing. Means now we are testing the entire software together, right? Whenever the testing is conducted onto a complete integrated system to evaluate the system's compliance with its specified requirement, then that type of the testing is called as my system testing. So whenever we are talking about the levels of the testing or the breakdown of the testing into the various level, we talk about it into the three parts. We talk about the unit level testing, we talk about the integrated testing, and then we talk about the system level testing. Unit level testing is generally discusses about the least or testing onto the smallest part of that particular code. Integration testing discusses about testing onto the aggregated modules or testing that is being performed after joining the modules. Then that kind of the testing is called as the integration testing. And after that, we are onto the system testing, whenever the testing is performed onto the entire system or onto the complete software in order to check whether the software is meeting the requirements specified, then that kind of the testing is called as my system testing. So these are the important points in the case of my levels of testing. Then after that, where is that? These examples I'll take into the next class. First, we will complete this part. Then after that, we are going to come on to the debugging part. All these levels of testings are cleared or not? Unit testing, integration testing, and the system testing?
Yes.
Yes.
Okay.
Sorry, mom. System testing. It means what? Please, little short description to give us about the system testing.
Mhm. You just read the first line. It says that system testing is basically performed before delivering the system to the customer, right? We wanted to deliver. Now the time has arrived that our unit testing is fine, our integration testing is fine. Okay. Now we wanted to deliver our software system to the customer. So before delivering that software system to the customer, what the testing team is do, it is just going to make the software to go through the final testing, and that final testing is my system testing. System means software system, the project,
Yes,
software project which needs to be developed, whether it has been developed in the manner that is being asked by the customer. So whenever the testing is performed onto the system level, and according to the specifications made by the customer, then that kind of the testing is called as my system level testing. Now the entire software is being tested. Okay. This is the input I'm giving to this particular software, and this is the expected output, whether the expected output is coming or not coming. So that is basically comes under the system level testing.
yes, thank you.
Okay. Now the next thing is my debugging. Debugging basically consists of two things. Okay, debugging is the combination of two activities. The first thing that comes into my debugging part is to locate the error or to locate the bug. Bug is basically a kind of the error. Fine. To locate that error in the code, in which line that particular error has come or in which line that particular bug has arisen, is locating that particular bug is the first function in the case of the debugging, and then fixing that particular error is the second part in the case of the debugging. So debugging is basically a combination of two parts, I will say, and the first one is to locate the error and the second part is to just fix that error. So fixing the error also comes in the case of the debugging, whereas in the case of the testing, we are just finding the faults, we are just finding the errors. Rather, in the case of the debugging, we are just trying to find out the bug, and then we are just trying to fixing that bug, we are just trying to clear that error, we are just trying to remove that error. So that comes under my debugging thing. There are two outcomes of the debugging. The first outcome is the cause will be found and necessary action such as correction and the removal will be taken. And the second outcome could be the cause will not be found. Cause of what? The cause of occurrence of the bug. In the case of the first outcome, the cause of the occurrence of the bug will be found, and then the necessary action for the correction of that particular bug will be taken up, and that bug will be removed. And second situation that could arise is that what is the cause of arise of that bug will not be able to found, right? So in the case of the debugging, these two important things which could happen, and it is always necessary to know the cause of any error, why that error has arise, so that it doesn't arise in the coming future. That is why we always focusing on to the cause of arise of that particular error. Then we have got the characteristic of the bug. Just a second. Okay, what are all the characteristic of the bug? The first characteristic of the bug is that the symptoms and the cause may be geographically remote, that we will not be able to locate that bug. It will be very difficult for the debugging team to locate that bug geographically. So it is one of the characteristic of the bug. The second could be the symptoms may disappear when another error is corrected. Means the bug can eradicate its symptoms. They may disappear temporarily whenever the another error is corrected. It also happens whenever you perform the coding pattern, there are certain errors that comes into your code, right? And it happens that when you remove the error from one line of your code, temporarily the error from the another line also disappears. So this temporary disappearance of the bug is another characteristic of your bug, right? Next is the symptoms may actually be caused by non-errors. It is always a possibility that the bug has arisen because of the non-errors, but those conditions, for example the round off values if you have taken, or any inaccurate values or in any inaccuracies of the round off errors can be taken into can be can be considered as one of the factor for the occurrence of any particular bug. Then the symptoms may be caused by human error, any, for example, any spelling mistake you made in the coding part, right? For example, you're writing the for loop, and in spite of writing the FOR, you are writing FORE. So all these human errors can also be a characteristic of the bug. Next is the symptoms may be a result of the timing problem rather than the processing problem. Your compiler is taking a lot of amount of time in processing that particular program, so that also may result into the bug. Then it may be difficult to accurately reproduce the input conditions. It is also maybe the situation that the input conditions which needs to be given to that particular uh, program, they are difficult to produce accurately. Then after that, the symptoms may be intermittent, means they are not continuous symptoms. They are arising for the certain amount of the time and then they are disappearing. So there could be sometimes some types of the symptoms which can be intermittent in nature, and then the symptoms may be due to the causes that are distributed across a number of tasks running or different processes. So this could be another kind of the situation in which the symptoms may arise due to the causes which are distributed or which are like spreaded across a number of the tasks running or onto the different processors, or a number of the processors are being used, a number of the tasks are being running. So those different tasks and the different processes may also causes a number of the symptoms to occur. Symptoms of what? Symptoms of occurrence of the bugs. So these are all basically the characteristics of the bugs, which are just representing to us how or what are all the symptoms of the occurrence of any bugs. Now, the life cycle of a debugging task. The following are the various steps involved into the debugging. First is the defect identification. Next is the defect analysis, and then we have the defect resolution. So defect identification or confirmation is what? That this is the defect that has been identified, this is the defect that has been located, and after the proper analysis or after the checking of that particular defect, it has been confirmed that this is the bug that is actually happening. Then whenever the defect is being identified, whenever the defect is being checked, or whenever the defect is being pointed out, then the analysis of that particular defect is being performed. So that why that defect has occurred, what is the cause of that defect, whether it has occurred because of any of the human error or because of the problem of the compiler, or what is the why this defect has arisen, is basically taken into consideration in the case of the defect analysis. After that, when the analysis has been performed properly according to all the analytical parameters, then we moved on to the resolution of that defect, that now how this defect is going to be removed. So that could be achieved with the help of the brute force technique, by the help of the backtracking technique, or with the help of the cause elimination technique. In all the three techniques of removing the defect, the brute force technique is the most popular technique, and here we apply the brute force debugging method when all else fails. That means time traces are invoked and the process is loaded with the right statement. What is the brute force technique? Nobody knows. Huh?
Excuse me, ma'am.
हाँ जी बताइए.
What did you say?
Brute force. I'm just asking you, what is brute force technique?
Brute force.
Hmm.
I don't know.
You don't know, na? So you are studying the algorithm. Just revise your algorithm part. You will be knowing what is brute force. I'm not going to explain it here. You
Mom,
must know what is brute force technique.
I say something.
Huh.
Brute force approach. Yeah.
Brute force approach. Yes, what it is?
It means brute force. You ask brute force approach or technique?
I'm asking you brute force approach. What is brute force approach? Not bread first technique. Brute force.
Is is an algorithm, yeah?
Yes.
Is a simple, comprehensive search target that systematically explores every
Yes.
point unit problem.
Yes. That is brute force technique.
Yes.
Ma'am,
Yes. Yes.
in brute force approach,
Hmm.
we find each and every solution, then
That is
we check
possible.
them, and yeah, then
Yes.
final feasible solution is find.
Okay. So that is now it's fine that you all know about the brute force technique, and this technique is again applied into resolution of your defect also, right? You have found out the defect, you have analyzed the defect, and now you wanted to resolve it. So brute force technique is applied for the resolution of that particular defect. That whatever be the error, whatever be the bug, every possible solution of that particular bug is taken into consideration, and then the best possible solution is then implemented. After that, backtracking is being performed. It could be the another approach that could be performed. Backtracking means we start moving from last to first, right? We started to check our program from the end of the program, and then we start moving till the start of the program. That is backtracking. Means we are moving into the back direction, and wherever we found the error, then at that particular place we just resolve the error. Then we see that after resolving this particular error in this particular line, whether it is affecting the another part of the program or not. That is why we check the entire program in the case of the backtracking, and we just go from end to starting of that particular program. We just keep on removing the errors, and we keep on checking whether what is the effect of removing this error, whether it is affecting the another part of the program or not. Then in the third kind of the approach, which is my cause elimination approach, a list of possible causes of an error are identified, and the tests are conducted until each one is eliminated. Now in the cause elimination, as the name indicate, what is the cause of the occurrence of this error is first of all found out, and then in spite of eliminating anything, you just eliminate the cause, right? That because of this particular line, my error is occurring into line number 18 of my program. So I'll just try to make use of a particular strategy, and I'll just remove the cause because of which the error is occurring, right? The root cause. Fine. So in these approaches, these are the three kind of the approaches that is being followed in the case of the debugging approach, or these are the kind of the strategies that is being followed for removing the error. It could be the brute force approach, it could be the backtracking approach, and it could be the cause elimination approach. I think this much is enough for today, right? We will be continuing further in our next class. Is it fine?
Yes, ma'am, fine.
Yes,
I'll
ma'am.
just stop presenting and stop the recording also. Just a second.